In this lesson, I want to quickly take you through how to do everything from this chapter using your TI-84. So please be sure that before you've viewed this video that you've watched how to find a z-score, etc., or none of this will make sense to you. So I'm looking at a question that we went through in our notes previously. We have an SAT verbal score of 680 and they follow a normal model of 500, 100. What percent of SAT score takers did you score better than? So notice here I can do this two different ways. I can do this using the z-score, so notice here I've already computed the z-score, observed of 680 minus expected of 500 over 100, and that's a z-score of 1.8. So if I want to use my TI-84 to find the p-value using the z-score, or p-value meaning the percentage. So I'm looking for the percent of SAT takers I did better than. So on my normal model, 1.8 is obviously to the right, and I'm looking for everybody to the left of me, everyone I did better than. So that's going to be a large percentage over 50%. So I can do this two ways. Either way, I'm going to click Second and Vars, which is of course the distribution menu, and I'm choosing the normal distribution, and I'm going to choose CDF because CDF stands for cumulative distribution function. In this case, my lower bound is negative infinity. Notice they're nice enough already to go ahead and plug in -1 e to the 99, which basically means it's a very, very teeny tiny number. If that's not there for you, don't worry about it. I use a score of -10,000 because a z-score of -10,000 would be 10,000 standard deviations below the mean, which is plenty. My upper limit then would be my z-score of 1.8. Oops, I forgot my 1.8. And then I'm going to leave my mean and standard deviation as 0 and 1 respectively. And notice I'm going to end up with 0.964, which is what I have here. Now I also want you to notice that I could do this without finding the z-score. So if I were being lazy and didn't have to find the z-score, say for a MyStatLab question, just needed to find the percentage or probability, then I could do norm CDF, and I'm just going to cheat here and do second enter, and second enter gives you whatever you have just entered in your calculator again. And in this case, I'm going to change the 1.8 to my actual raw score of 680. My mean is now 500. My standard deviation is now 100. So if I'm using the raw score, I have to use the raw normal model, not 0 and 1. But notice it gives me the exact same answer again. Of course, we also have questions where we're finding it between two values. That's very easy to do. Again, second vars will give me my norm CDF. Notice again it's asking for the lower limit and upper limit. Now if I'm going between 450 and 600, in the middle here is 500, so I'm looking for whatever this area is essentially what I'm finding. Now the easy way, where I don't have to find z-scores, is I of course would plug in 450 and 600 and change the mean to 500 and standard deviation to 100, because then I don't actually have to do any work. I'm just letting my calculator find the answer for me, which is great. So 0.5328. I could again do the exact same thing, but change this to z-scores. So if the question required me to find a z-score, I would put -0.5, 1, if my fingers would work correctly, and then my mean of 0 and my standard deviation of 1, and then just get rid of the rest of that. And again, notice I'm going to get the exact same answer again. Obviously, not turning it into z-scores is easier, but it's good that you would know both ways of how to do that. And the last thing that you would want to know how to do is to do z's in reverse. So again, there's two ways to do this. I've only shown you one on this slide here, but I'll show you both ways here right now. So let me show you the kind of easier way first. If I'm finding the inverse percentage, so this is when I'm given a percentage in the question, so top 10%, top 5%, whatever. Whenever you're given the percentage, I'm still going to do second and vars, and I'm going to go to inverse normal. So inverse normal is, of course, when we're given the percentage. Now, here's where you have to kind of be careful. I'm in this question saying the top 10%. So here's my value. Only admits the top 10%. So there's 10% on this side, but on this side there's 90%. So you kind of have to choose. Notice here on my screen on the right, it's asking if I want left, center, or right. And so left, center, or right would mean that I could choose to use the 10% and do that on the right, or I could choose to use 90% and do that on the left, because that's how much I have on each side of my value. So let's just do both of those real quick, again using the mean of 500 and the standard deviation of 100. So on the screen I've already shown you that the 90 works, so I'm going to show you that this will work. Again, 10% to the right should give me the exact same amount, which it does. These values match. If I needed to do it the other way, then this would have to be left instead, and that first value would have to be 0.9. But I also want to show you how that works if I want to actually find the z-score. So then I would go to inverse norm, and I'm going to go back to 0.9 just for fun. Make sure you're paying attention. If I did 0.9, mean of 0, standard deviation of 1, and I said to the left, oops, I forget to arrow down sometimes, I apologize. Notice that gives me a z-score of 1.282, we'll call it. Or again, if I would have done the exact same thing, but instead chosen 0.1 and to the right, again I get the exact same z-score. Now why is that helpful? Because sometimes you actually have to find the z-score and show the work. And so in this case I would be trying to find my observed, which is x. My expected is 500, my standard deviation is 100. Then of course I could do the math here to find my value. This would be 128.2 equals x minus 500. This would be 628.2 equals x, and notice that's essentially what I have here.